everyone. In today's video, we are going to cover section 3.6, types of triangles. After studying this section, you'll be able to name the various types of triangles and their parts. We can name triangles two different ways, based off their sides and based off their angles. Off their angles, we have three different ways we can name triangles. So a scalene triangle is a triangle in which no two sides are congruent. Now an isosceles triangle is a triangle in which at least two sides are congruent. In an isosceles triangle, I have different names for the sides and for the angles. So in triangle DEF, the sides that are congruent are DE and DF. These are called the legs of my triangle. Then side EF is called the base. Now angle E and angle F are called my base angles. We'll learn later that these angles are actually congruent. And then angle D is called my vertex angle. Now in triangle RST, again, the sides that are congruent are called my legs. So side RS and RT are my legs, while side ST is my base. Angle S and angle T are my base angles, and angle R is my vertex angle. An equilateral triangle is a triangle in which all sides are congruent. Now we can also name triangles based off their angles. So an equiangular triangle is a triangle in which all angles are congruent. We'll also note that an equiangular triangle is also equilateral. So if all angles are congruent, then all sides are congruent. And if all sides are congruent, then all angles will be congruent. This only works for triangles, however, it doesn't work for other polygons. An acute triangle is a triangle in which all angles are acute, so less than 90 degrees. A right triangle is a triangle that contains a right angle. Remember, the side opposite the right angle is called the hypotenuse, and the sides adjacent to the right angle, or touching the right angle, are called the legs. And an obtuse triangle is a triangle in which one of the angles is obtuse, or greater than 90 degrees. Now looking at our sample problems, in problem 1, I'm given that angle CBD is 70 degrees, and I want to prove that triangle ABC is obtuse. If I want to prove that a triangle is obtuse, I need to show that it contains an angle that is obtuse, so an angle that is bigger than 90 degrees. Angle CBD and angle ABC make a straight line, which would mean those two angles add up to 180 degrees. If angle CBD is 70 degrees, that would make angle ABC 110 degrees, because 180 minus 70 is 110. So if angle ABC is 110 degrees, that's an obtuse angle, making triangle ABC obtuse because it contains an obtuse angle. Looking at problem 2, I'm given side EG is equal to side FH, so this side is equal to this side. Side EF is bigger than side EG. I want to prove that triangle EFG is scalene. So if triangle EFG is scalene, that means that no sides are congruent. If I look at side EG and FH, if I take away side GH here, that would leave me with side FG, which would tell me that this is smaller than side EG. And since EF is bigger than EG, that tells me that all three of my sides are different sizes. Therefore, my triangle would be scalene because no sides are congruent. Looking at this in a paragraph proof, I would have something like this. Now looking at problem 3, I have the following givens, and I want to prove that triangle KPM is isosceles. So this triangle is isosceles. In order to prove that this triangle is isosceles, I need to show that side KP is congruent to side MP, because the definition of an isosceles triangle is a triangle which at least two sides are congruent. So if I can show those sides congruent, then I would have an isosceles triangle. Now looking at where those sides are located within triangles that I could possibly prove, they're located in triangle JKP as well as triangle OPM, because that's the side of the triangle. They're also located within triangle JKM and triangle OKM, because I could use my given of side JP congruent to side PO and subtract that from JM and OK to give me KP congruent to MP. So I could prove either sets of these triangles congruent in order to prove that KP is congruent to MP. So let's look at the overlapping triangles, triangle JKM and triangle OKM, and let's see if we can prove those congruent. So if I draw a little diagram to the side to give me a better view of what I'm looking at, these would be my two overlapping triangles. I'm given angle 1 congruent to angle 3 and angle 2 congruent to angle 4. Angle 2 and angle 4 are the little tiny angles in my triangle, so those angles are congruent. If I add angle 1 and 2 and angle 3 and 4, that gives me the larger angles congruent by the addition property. Then I could say that KM is congruent to KM by reflexive, and notice in my overlapping triangles I now have angle side angle. So my overlapping triangles are congruent, which would give me side KO congruent to side MJ. Then I could use subtraction of side JP and PO to give me side KP congruent to side MP. Then, based off the definition of isosceles triangle KPM is isosceles. So listing this in my proof, I would have my first given of angle 1 is congruent to angle 3, then angle 2 is congruent to angle 4. Now, angle JKM is congruent to angle OMK by addition. Then side KM is congruent to side KM by reflexive, making my two overlapping triangles congruent by angle side angle. Then I can use CPCTC to give me side JM congruent to side KO. Now my last given, side JP is congruent to side PO. I'll use subtraction property to give me side KP is congruent to side MP. Now I know my triangle is isosceles, because if at least two sides of a triangle are congruent, the triangle is isosceles. Now if I show that the sides are congruent, I can use definition of isosceles triangle. If I don't show the sides are congruent, I can't use the definition of isosceles triangle. Because if I go back to the definition of isosceles triangle, it talks about the sides, not the angles. So I have to show my sides are congruent in order to say definition of isosceles triangle. In today's lesson, we learned how to name triangles based off their angles and their sides. Scalene triangle has no sides congruent. Isosceles triangle has at least two sides congruent. Equilateral triangle has all sides congruent. Equal angular triangle has all angles congruent. Acute triangle has all angles less than 90. Right triangle has one angle is 90. And an obtuse triangle is one angle greater than 90. That's a wrap on today's video. We'll see you in the next one.